Chapter 1.5.4 Gateway API. The text discusses making network services accessible through an extensible and role-oriented configuration mechanism. The Gateway API is an add-on that offers various API kinds for dynamic infrastructure provisioning and advanced traffic routing. Design principles. Gateway API was designed with the following principles in mind: role-oriented, portable, expressive, and extensible. The API is modeled after organizational roles such as infrastructure provider, cluster operator, and application developer. Gateway API specifications are defined as custom resources and are supported by multiple implementations. The API provides functionality for common traffic routing use cases and allows for granular customization at various layers. This design aims to streamline Kubernetes service networking and provide flexibility for managing applications running in clusters. Resource model. Gateway API consists of three stable API kinds: gateway class, gateway, and HTTP route. Gateway class defines a set of gateways with common configuration managed by a controller that implements the class. Gateway defines an instance of traffic handling infrastructure, such as a cloud load balancer. HTTP route specifies HTTP-specific rules for mapping traffic from a gateway listener to backend network endpoints, often represented as a service. The Gateway API is organized into different API kinds with interdependent relationships to support the role-oriented nature of organizations. A gateway object is associated with exactly one gateway class, which describes the controller responsible for managing gateways of that class. Route kinds, such as HTTP route, are then associated with gateways, forming a bidirectional trust model with routes. Gateways can be implemented by different controllers with different configurations, each referencing a gateway class that contains the controller name. A gateway describes an instance of traffic handling infrastructure, filtering, balancing, or splitting traffic for backends like a service. An HTTP route specifies routing behavior of HTTP requests from a gateway listener to backend network endpoints, applying configuration to the underlying gateway implementation. Overall, Gateway API provides a structured way to manage and configure gateways, traffic handling infrastructure, and routing behavior in an organization's network environment. Request flow. In this example, HTTP traffic is directed to a service through a gateway and HTTP route. The process begins with the client preparing an HTTP request for a specific URL. The client's DNS resolver then finds the IP address associated with the gateway. The client sends the request to this IP address, where the reverse proxy receives it and matches it to a configuration based on the host header. The reverse proxy can also perform additional matching or modification of the request based on the HTTP route rules before forwarding it to one or more backends. Conformance. The Gateway API is extensively used and includes a wide range of features. To ensure consistency across implementations, clear conformance definitions and testing are necessary. The conformance documentation provides information on release channels, support levels, and how to conduct conformance tests. It is important to follow these guidelines to ensure a consistent experience with the API. Migrating from Ingress. The Gateway API is the updated version of the Ingress API, but it does not include the Ingress kind. Therefore, a one-time conversion is required to migrate existing Ingress resources to Gateway API resources. For more information on how to do this, refer to the Ingress Migration Guide for detailed instructions and guidance.